Alright. Okay, we'll come back to this page in a second. Alright, your subcourse AL0926 Basic Hydraulic System and Components, Edition A, API Institute Professional Development. Alright, Lesson 2, Basic Construction Operation Hydraulic Actuating Devices, Flow Control Directional Devices. Alright, lesson description. In the lesson, you will learn basic construction, operation, hydraulic action devices, flow control, directional devices, introduction. So, fluid pressure produced in pumps can also be used to move subject. The pressure must be converted into usable forces by means of actuating unit. The device is called an actuating cylinder, used to imparted power straight line motion mechanism. Hydraulic system must also have the devices to control the direct fluid pressure for the various of the components. Such devices include selector valves, check valves, ratchet valves, irreversible valves, sequence valves, priority valves, each described in the paragraph below. Actuating cylinder. As basic actuating cylinder consists of the cylinder housing one or more piston for the piston rod, one or more seal with the cylinder housing contained with a polished bore, where the piston operates on one or more parts which of the fluid enter the leave of the bore, with the piston rod forms the assembly which move the forward back in the cylinder bore. The piston rod moves in and out for the cylinder housing through the opening of the one and both ends. The seal used to prevent leakage between the piston and cylinder bore, between the piston rod and the housing. Two major types of actuating cylinders are single action and double action. Single action actuating cylinder. The single actuating cylinder shown in Figure 2.1 consists of the cylinder housing, one fluid port with piston, a rod assembly, piston return spring, and a seal. The wheel seals. When no pressure is applied with the piston with the return spring holds and rod assembly with a retracted piston with the hydraulic pressure equipped, applied with the inlet port piston seal into the cylinder wall with the O-ring, does not allow the fluid to pass the cuff of the piston to extend. The piston rod extend with the return spring compresses the vent with the spring side with the piston allow the air to escape. Pressure is to leave the return spring force of the piston retract, pushing the fluid out of the cylinder. Wiper is then housing a wiper, and the housing keeps the piston rod clean. The cylinder with the pressure operated in one direction only. Three-way control valve is normally used to control the cylinder operation. Your double action actuating cylinder. Double action actuating cylinder consists of the cylinder as in port, either with a piston rod assembly extended through one end of each of the end of the cylinder. Figure 2.2. Pressure applied with the port applied to port A causes the piston to extend, forcing fluid with the opposite end of the out of piston port B. Which pressure is applied with the port B, the piston rod retracts and forcing fluid out of the chamber. Opposite chamber out for the port A. Single action actuating cylinder. So you'd have the fluid port, your piston packaging O-ring, mounting holes, return spring, and a vent with a rod wiper and a piston rod. That's your typical single action. The type of the cylinder are both directions, hydraulic pressure, single. Selector valve, normally used with the double action actuating cylinder. Selector valve are discussed in the next paragraph. Alright, 2.2 shows the double action waiting cylinder, port A, port B. Selector valves, hydraulic system to control the direction operation mechanism. Selector valves, also referred to as directional control valves. The control valves provides pathways simultaneously flow with two streams of fluid under pressure for the actuating unit and others return stream out of actuating unit. The selector valves have various numbers of pilot ports demanding with the requirements of the system in which the valve is used. With the selector valve with the four ports most commonly used referred to as a four-way valve. Selector valves are further discussed in closed center of the open center types. Closed center selector valve. When a closed center selector valve is placed in the off position, the pressure package is blocked into fluid of flow. The flow of fluid. Therefore, no fluid can flow through the pressure port with the hydraulic system stay with the operating pressure at all times with the four-way closed center with the selector valve with the most commonly used selector valve in a aircraft hydraulic. There are two types, the rotor type. Closed center selector with the valve with the shown figure 2.3 with the rotor's valve with the device and with the rotor with thicker circular disc drilled with the fluid and passage with place in the various operation positions by relative movement of the valve control handle. If in the off position, the rotor is positioned to close all ports. If in the first on position, the rotor interconnects the pressure port with the number one cylinder port. Number two cylinder port is the open return. In the second on position, reverse takes place. The spool types closed center selector valve shown in figure 2.4 with the valve is housing container four ports and spool pilot valve. The spool is made from a round shaft having a machine section forming the space for the allow the hydraulic fluid to pass. A drilled passage in the spool interconnects with the two ends of the chamber. The selector valve with larger diameters of spools or bearing and sealing strips that are called lands. See glossary and operating with a pot pool spool vertical identical to the rotor type. All right, shows your typical rotor closed selector valve. You have a cylinder port 2 rotor, reservoir relief pressure valve, cylinder valve off, and actuating pipe is double two-way selector, two-way double action piston, selector valve on. Selector valve on, so you can switch the direction of your typical rotor closed center selector by the rotor itself. Alright, this shows your typical spool closed center selector. Shows the cylinder in the off position, piston cylinder 1 and cylinder 2, the extension spool used for control. Pressure through cylinder 1, pressure through cylinder 2, second pump pressure, closing then, open center selector valve. With an external appearance of the open center selector valve looks like a closed center one, like closed center valve. The open center selector valve has 4 ports, operates on and off 2 open. So the difference between closed center with the open center valve and the off position from the closed center valve with none of the ports are open. Each of the off position open center of the valve with the pressure return ports open. Each of the other valves are off in the piston. Output selection pump system pump is returned through the selector valve of the reservoir. Little resistance hence to the opening center with the opening pressure is present with the actuating unit being operated. An open center rotor type selected valve shown in figure 2.5 is seen with the valve with the off position fluid from the pump enters the pressure port, passes through the open center passage rotor and back to the reservoir. When the valve is in either 2 on positions, it functions the same in closed center valve as a closed center valve. Alright, show the off position of your cylinder port 1 and 2, and then a return port through the relief valve with the selector valve pump and reservoir selector in the on position, first on position, second on position. Open center spool type selector valve shown in figure 2.6. Notice the valve differs from the closed center type. In a third land, machine on the spool land is used to cover the pressure port with a valve in the off position that provides inner passage for the spool with allows fluid for the pump to return reservoir. Operation in both on positions is the same as closed center selector valve. Alright, shows your off position cylinder 1 and cylinder 2 transfer. One of the several transfer hole 1 through the several extension spool for control. And then it shows your first on position, typical on center spool selector. Hydraulic system classified open center, closed center, depending on the type of the selector of the valve that's used in the open center that has more than one selector valve with the valves arranged beyond the other in series. Closed center system, the valves are all arranged parallel to each other. The open center system, the fluid flow has but no pressure system when the selector valve is off. Closed center system, the fluid used is under pressure with the system hydraulic pump operating both systems. Discuss the paragraph as follows. Your open center system, figure 2.7, shows the basic open cylinder center hydraulic system, which is relief of the valve limited pressure of the was mentioned earlier in their type. Shows the pump, the reservoir, relief valve, your selector valves off, and then shows your the wavy line, the return, the pressure, and the suction, reservoir pump, pressure, the return, and the suction. The reservoir is getting sucked through the pump and then pushes the reef valve up, which returns and through the returns, and then the actuating device selector valve turns like. As the fluid has no pressure until the sum of the hydraulic pressure device is operated, the selector valve off of the fluid flow with the reservoir to the pump through the open circuit center patch of each of the valve back to the reservoir. No restriction exists in the system, therefore no pressure is present when one valve is placed in the operating position. The restriction is created with the device. The valve controls fluid then flows under the pressure of the hydraulic device. Closed center system, figure 2.8 shows the basic closed center system fluid and the under pressure throughout the closed system center. The pumping is operating with selector valves in the off position. The fluid control through the closed center, and then and causes the pressure to build up in the system, and they are able to time the electric valve to turn on. The relief valve is used to keep the system pressure from the going above the determined amount of all valves off. So your bypass pressure return line is the diagonal to the suction line, and then the pressure line. Pressure is made through actuating unit 1, and then actuating 1 is pressure, and then it returns, and so does pressure selector valve C, and then the return goes back to the relief valve in between the pressure and the reservoir. Alright, hydraulic servo. The servo of the combination selector valve of the Q actuating cylinder in a single unit with the pilot valve of the servo is open with the operator automatically code for the movement of the servo. Our actuating unit is explained below. Hydraulic servos are used in aircraft to precise control as necessary over the distance of component movements. Your hydraulic servo. Figure 2.9 shows the typical hydro servo that operates with the pilot valve placed in the center of the pressure is directed to one chamber of the power piston, and the other chamber is open to return flow. So the power piston travel, the pilot valve housing travel because of the two attached. The pilot valve itself is being stationary by operator. The ports again to become blocked by lands, a pilot valve stopping piston that has moved the reach of the distance. So you have your bypass shown in bypass valve, power piston, servo housing, pressure selector pilot valve, and sloppy link. The servo sloppy link. Notice the servo sloppy link figure 2.9 and the connection between the control leak hinge pilot valve servo piston rod. Its purpose is to permit the servo piston to be moved either by fluid pressure or manually. So the sloppy link provides the limited amount of slack between the connection linkages and pilot valve. Because of the slack between the piston rod and the connection linkage, pilot valve can be moved on position and the connecting linkage without moving the piston rod. Once again, that is because the slack on the piston rod connecting the linkage of the pilot valve can be moved to the on position by connecting linkage without moving the piston rod. Alright, bypass valve. The bypass valve is provided with a minimized resistance servo piston movement when it's moved, and when it must be moved manually, the valve opens automatically where there's no operating pressure onto the servo. This allows the fluid to flow freely between the chambers on each side of the piston. An irreversible valve during normal aircraft operation. External force of the aircraft control surfaces such as rotor blades, ailerons tend to move servo cylinders. The movement creates a pump-like action servo called the feedback. The reversible valve presents a feedback with servo to control stick. Figure 210 shows a simplified schematic version of irreversible valve. The broken line block represents the housing. So figure 210 shows your simplified irreversible valve. You have your servo and then servo piston. Your shows the arrows show the pass of the servo going to the reservoir and then passing through a port through a relief valve, pushing on a spring with a relief valve, and then a port from the pump through the port into a check valve to the port to the servo piston, and back between the things you have a irreversible valve. So yeah. Alright, the check valve allows the fluid to pump through the flow of the normal direction shown with the arrow. The force feeds the D tends to move the servo piston opposite direction. Pump produces the pressure tends the fluid back with a reversible valve. The check valve keeps the servo piston yielding feedback, blocking the rearward flow of fluid. The relief valve is safe the device to the limit of the pressure produced by feedback-induced movement of the servo piston. It opens to allow the fluid to bypass the return line and the feedback pressure exceed with a predetermined safe limit. Alright, your ratchet valve. The ratchet valve is used with a double action actuating cylinder to aid in holding loading piston where it has been moved. The ratchet valve ensures that there is trapped fluid on each side of the actuating cylinder necessary for the cylinder to lock a load against a movement in any other direction. Typical ratchet valve shown in Figure 211 consists of the housing with the 4 ports, polished bore, 2-ball check valve pistons. The piston has extensions on either end of the unseat with the 2-ball check valves. The spring keeps the valves on their seats with no pressure applied to the system. Alright, it shows the selector valve, the typical ratchet valve in A and B positions. The A position has the selector valve off, and then port A and port 1 and port 2 are even, where the balls and the return springs centered. Selector valve on, the port 1 and port 2 move, and they are trapped in between the cylinder and an opening in its path. So this is a typical actuating ratchet valve. Alright, valve operation with no pressure. Figure 211, the ratchet valve shown with the no pressure applied with the piston centered with the bore with the ball of the check valves are closed. This locks the actuating cylinder and piston by trapping all fluid in the cylinder. Valve operating with the pressure applied. In B, Figure 211, the ratchet valve shown with the pressure applied with the port 1, the force of the piston to the right unseats the ball check valve with the pressure entering port 1. Also unseats the ball check valve on the left side of the fluid, then flows from the ratchet valve with the piston moved to the right. Your check valve. The check valve is installed with a hydraulic system to control the direction of the hydraulic fluid. With the check valve will allow free flow of the fluid in one direction, but no flow of the or restricted one to the other direction. Two general design check valve. One has its housing connected to another components with a tubing and hose. Check valves are either of this design are called inline check valves. If in the other design the check valve is part of another component, it is called an integral check valve. It will not be covered because its operation is identical to the inline check valve. These two types of inline check valve, simple and orifice, are described in the following paragraphs. Simple inline check valve is illustrated in Figure 212. The simple inline check valve consists of the casing, inlet, outlet, ports, ball spring assembly. The ball spring permit fluid flow in one direction, block the flow completely in the opposite direction. Fluid pressure forces the ball off the seat again for the pressure spring pressure permitting the fluid to flow. When the flow stops, the spring forces the ball against the seat, blocking reverse flow. Orifice inline check valve. The orifice check valve is shown in Figure 213 is due to the allow the free flow of the one direction, limited flow of the opposite direction. This is accomplished by drilling a passage in the valve seat and connecting the inlet side of the valve to the outlet side. Or sequence valve shown in Figure 214 play for the hydraulic system to lay with the operation of one portion of the system and another portion of the same system function for shows this is basically it shows a simple inline check valve, outlet port, inlet port, simple Tyler inlet check valve ball type. Shows inlet and outlet port, flow direction marking type of the inlet, outlet port, drill passage, flow direction marking orifice type of the inlet check valve. So you have a simple inline check valve, and then you have an orifice check valve. They're basically identical. Example: it would be undesirable to landing gear for the retract of the gear compartment's doors are completely open. A sequence valve actuated with a full open door would allow the pressure to enter the landing gear retract the cylinder. Sequence valve consists of the valve body, 2 ports, a ball spring loaded, a closed position spring loaded plunger. The compressing plunger's off-seat of the ball allows the passage of fluid desired to actuate. A typical sequence of valve manual mechanically operated can be solenoid operated means of micro switches. In either case, the valve is operated at the completion of one-phase, multi-phase cylinder hydraulic cycle. Alright, so Figure 214 shows port A, your mechanically actuated sequence valve has 2 springs and then 1 piston valve, a spring port 1, port 2, a ball check valve, and a spring underneath the valve and a piston of the valve. And the valve breathes in the from pressure from port 1, goes through, it goes to port 2 to the activator. Alright, your priority valve. A priority valve is installed with a hydraulic system to provide adequate fluid flow, but the essential unit of the valve is installed with a line between the non-essential actuating unit and the source of pressure. It permits freely unrestricted flow of the fluid of non-essential units unloaded against system pressure. Normal, when the system pressure below the drop below is normal, the priority valve will automatically reduce the flow of the fluid to the non-essential units. The priority valve resembles the check valve with both external appearance and internal operation. Spring acts, hollow piston maintained with contact with the valve seat. With no system pressure for the priority valve with the spring-loaded piston, clove with the piston again for the valve seat. But as the pressure is applied with the system, fluid passes through the valve seat and also through drilled passage for the actuating the face of the piston. When the normal and pressure the piston moves again with the spring tension allowing with the passage of fluid. Pressure decreases with the spring force the piston to supply seat, assuring the supply of fluid to the essential portion of the system. Her typical priority valve shows the outlet port, the vent, and your spring-loaded devicing valve and an valve seat with the orifice and the inlet port, and then you have your B valve closed, permitting only limited flow. Alright, summary. The hydraulic actuating cylinder is used to convert fluid pressure into a straight line motion. The two types of single to double action selector valves are used the actuating cylinder to control these operations. The typical selector valve has two on positions to extend and retract cylinder on and off position. Hydraulic systems are classified either as open center, closed center. Open centers have only open center selector valves. Closed centers have only closed center selector valves. Hydraulic servo physical combination actuator selector valve. They are used when permissible control of the movement is required. The normal final with a flight with the control system of aircraft's irreversible valves used with the inline servo prevent field back to the flight controls. Your ratchet valve locking device actuating cylinders where they hold the cylinders in any desired position. Fluid flow within one direction is required with a simple line check valve with the U with the flow with one direction restricted flow in the opposite direction with the ORS check valve is used. When more than one function must be performed, the hydraulic system definite order must be followed. Sequence valves are used. Sequence valves ensure the proper order of operation maintained with the reduction pressure fluid flow. Certain components can be cut out with the hydraulic system to ensure the adequate supply of fluid. Essential components such as flight controls, priority valves are used to automatically shut off supply of fluid to non-essential components. Lesson 2 practice exam. Intentional page left blank, and then another page left blank, and the answer key. Another page left blank. Lesson 3 hydraulic pressure limiting control and sensing devices.